for 8.3, we're going to be talking about algebraic expressions. So we've talked about numerical expressions. That is something that just has numbers and operations. So if we know all of the values and we know what we're doing with them, we can write out the problem. That's a numerical expression. An algebraic expression is an expression that contains at least one variable. So it has one value that we don't know. So it could be, right, an X, a B, a C, any letter, and it can stand for anything. A variable can be a variety, right? It varies depending on the situation. So an algebraic expression could have numbers. It has to have at least one variable, and then it has the operations. What are we doing with those? So an algebraic expression example would look like Sam ran 6 miles a day for D days. So we do not know how many days he ran for, but we know every time he did run, he ran 6 miles each day. So if he ran 1 day, he would have ran 6 miles. If he ran 2 days, he would have ran 6 miles and 6 miles. If he would have ran 10 days, he would have done 6, 6, 6, 6, 6, 6, 6, 6, 6, 6, right? So we don't know how many days he ran for. It could change depending on the month, depending on the weather. But every time he does run, it's 6 miles. So we're going to write an algebraic expression to represent how many miles he ran. So then no matter what the number is of how many days he ran, we can plug it in, use that substitution, and solve for the problem. So I know he's doing 6 miles, and he did, right, 6 and 6. Add those together, or 6 times 2. If he ran for 3 days, 6, 6, 6. Repeated addition is multiplication. So I don't want to just add them on because I don't know how many I need to add. But if I multiply them, 6 times D, no matter how many days he ran, I can substitute that in, solve that expression, and that will tell me how many miles he ran total. Another way, a better way, I would say actually to write this is 6 groups of D. You put the variable and the number right next to each other. And it's just a math rule that you always put the number first. I have 6 of these, 6 D's. So if D, now it tells us D equals 7. Remember, this is not 67. This is 6 times 7. And that would equal 42. But we're not really solving it right now. You can put things in to test it out. I always like to say, if I did this, is not what I'm expecting to happen from that problem. The expression, remember, does not have an equal sign. It's just the problem that you would do. So let's take a look at some vocabulary words in these algebraic expressions. So our variable is a letter or symbol. Once we get into upper math, like we're in now, we don't really use symbols. Like sometimes you might have seen, like, what is this box equal? What is this star going to be? Once we are here in our math level, we just use letters. And lots of times people use X. Why? I don't know. They really should have picked a different number or letter because, right, X means multiply. So that's why we get rid of that multiply, is because lots of people use X as their variable. So I guess, like, right, X marks the spot, what goes there. So a variable is a letter or symbol used to represent a, let me make this a little bit smaller so we can read it all. So it's a letter or symbol used to represent an unknown value. So we do not know what it means yet. We could figure it out. We could be told, but this situation is representing a lot of different things. I think if I pick B amount of bananas every day from the store. How many bananas would I have, right? I'm doing the same thing over and over again, but I don't know how many days I do that for, things like that. There's something unknown about it. So the coefficient is the number that we multiply. So like when we had 6D, that number in front of the variable is called the coefficient. So co kind of means, right, like you're like a co-captain, your partners, your team. So those are a team working together. It says this many groups of the variable, and you always put that coefficient in the front. So a coefficient, I'm just going to copy this over really quick so I can use that same size. So a coefficient is the number multiplied by the variable. There we go. That's right, 6D. I could have 13R. I could have 42.6 G's. The coefficient is 6. The variable would be D. That's right, maybe there's dogs in this group. I've got 13 as my coefficient. The variable is R. So maybe that's how many minutes that you read every day. 42.6 is the coefficient. The variable is G. So like maybe that's how many grams different, like, I don't know, what weighs 42 grams? Pens weigh, okay? So like I have how many pens, I don't know, but each of them weighs this much. So the coefficient is the number in front. The variable is the letter that we don't know how many we have. Once we do know, that means we multiply, not just plug it in, multiply. Then we also can have constants in our expressions, and the constant is a set number. It's not going to change. So let's say that I have 8H plus 3. So let's kind of look through this. So I have 8, and it starts with an H, 8, maybe groups of hippos, and I don't know how many. Or maybe like they each weigh 8 tons. That's probably really giant. I don't know. I'm just making this up, guys. So how many hippos do we have? Maybe they, right, each have 8 kids or something. Every hippo has 8 kids in this group. So I don't know how many kids they have for this group, but then there's also these 3 extra hippo kids. So if there were, right, like 7 hippo parents, they each have 8 kids, plus these 3 extras, the constant would be this number that's not changing. Those 3 kids are not changing. Whether I have 4 hippo parents times 8, whether I have 19 sets of hippo parents that have 8 kids, I have 42 sets of hippo parents that each have 8 kids, there's always these 3 extra. That is constant, and it's not changing. So the constant is the number that you might add or subtract or divide. It does not have it might even multiply it, but it does not have a variable attached to it. It just is that number. So let's identify each of these pieces. So 4 is our constant. So I'm just going to write CON underneath that. 5 is the coefficient, and R is the variable. So I have 5 groups of R. We don't know what R is. We don't know how many that is yet, but then I'll always have these 4 extra. And you would, once we know what R is, you still would do this first, 5 times R, then add on the 4. Order of operations matters. So here we have 8 F's. So 8 is the coefficient. F is the variable. We have 3 E's. We have another coefficient and another variable. So this one does not have any constants. These 2 variables can change and vary and give us different answers every time. hey, here we have 7 times 6w minus 2. So 7 doesn't have anything with it. It is a constant. It is set. 6w's is our coefficient, right? These are kind of working together in a co-team. W is our variable. That's going to change. But then every time we're going to minus 2, that is a constant. So whatever's happening in your algebraic expression, if it's happening in a repeated amount, we write it as a coefficient and a variable, that multiplication problem. And then if something else just happens in there, then that is our constant. If that's going to happen every time, that's a constant. So coefficients are multiplied in front of a variable. Variables are letters that can change the value. And constants are things that always stay the same. And if you want them to add this first, then you've got to put parentheses around it. You still have to follow your order of operation rules, no matter what type of expression you are writing.